Something is wrong with the universe. Not wrong in a small way. Not wrong in a way that requires a minor correction to an existing theory. Wrong in a way that means everything we thought we knew about how the universe began, how it grew, and what it contains may need to be thrown out entirely and rebuilt from scratch. On Christmas Day 2021, a silent countdown ended with the thunder of engines rising from French Guiana. The James Webb Space Telescope, folded like a golden origami, left Earth behind on an Ariane 5 rocket. Over the next 2 weeks, Webb's deployment sequence played out with no margin for error, hundreds of mechanical actions, each one vital. The massive sunshield unfurled, layer by layer, shielding the instruments from the sun's relentless heat. 18 hexagonal mirror segments, each coated in gold and engineered to atomic precision, clicked into place. When fully assembled, Webb's primary mirror stretched 6.5 meters across, nearly 3 times the size of Hubble's. Its 4 scientific instruments, NIRCam, NIRSpec, MIRI, and NIRISS, were brought online as the observatory cooled to temperatures colder than Pluto. By July 2022, Webb was ready, staring deeper into the cosmos than any human-built eye before it. Inside Webb's gold mirrors, the temperature drops to less than 50 Kelvin, so cold that stray heat from a human hand would swamp the detectors. Each instrument is shielded from the sun by a 5-layer membrane thinner than a human hair, blocking 200,000 times more heat than it lets through. The mirror segments, aligned by actuators with nanometer precision, focus starlight to a sharp point, reaching the diffraction limit at 2 microns. During commissioning, wavefront sensing confirmed the optics were performing at or beyond their design. By 2022, the telescope's 4 instruments, NIRCam, NIRSpec, MIRI, and NIRISS, were tested, calibrated, and ready. Every pixel in Webb's first images carried proof. The observatory could see objects 100,000 times fainter than anything Hubble could reach in the infrared. The era of science had begun, and the data would be trusted to reveal whatever secrets the universe had to offer. Webb's first deep surveys sent shockwaves through the community. In images captured at redshifts between 10 and 12, when the universe was only about 400 to 700 million years old, astronomers found galaxies with stellar masses rivaling the modern Milky Way. Some tipped the scales at 100 billion solar masses, packed into compact, organized structures. The numbers defy expectation. Instead of a handful of faint smudges, Webb's detectors revealed a population density of around 1 in every 10,000 cubic megaparsecs. That is nearly 100 times more common than the most optimistic models had allowed. The statistical mismatch is not subtle. These early giants stand out at more than 5 sigma of predictions. For cosmologists, this is not a rounding error. It is the kind of gap that can't be patched with minor tweaks. The universe, it seems, was building massive, mature galaxies almost as soon as it could form stars, leaving theorists scrambling for answers. In the faint afterglow of the first galaxies, Webb's spectrographs locked onto a different kind of monster, quasars blazing from the edge of time. Their light, stretched across the cosmos, carries the fingerprints of supermassive black holes weighing more than 1 billion suns. One such object, measured at redshift 7.5, existed just 700 million years after the Big Bang. The math is unforgiving. To reach this mass, a black hole would need to double in size every 45 million years, growing at the Eddington limit without pause. Starting from the collapse of a single massive star, the timeline does not add up. Standard models cannot squeeze enough growth into such a short window. Some theorists suggest these giants began as massive seeds, direct collapses of primordial gas clouds, or that they fed in bursts far above the natural limit. Each explanation pushes against the boundaries of known physics. The paradox deepens, and the pattern of cosmic anomalies grows harder to ignore. A faint world, K2 18b, drifted into Webb's crosshairs, a planet orbiting a cool M dwarf 120 light-years away. During 3 separate transits, Webb's spectrograph caught a subtle dip at 6.9 microns. The absorption matched the signature of dimethyl sulfide, DMS, a molecule on Earth almost entirely produced by living cells in the ocean. Professor Niku Madhusudan led the team that ran the numbers. Their analysis showed a 3.2 sigma signal just above the threshold where chance becomes unlikely, but far from a smoking gun. The news rippled through the scientific world. A possible biosignature glimpsed on a planet outside our solar system. Yet caution held the headlines in check. DMS can, in theory, form through volcanic or photochemical processes, though these pathways are rare and uncertain. The team's own statement stressed the need for more data, more transits, more scrutiny. Still, the possibility lingers. An alien sky, touched by a molecule that, on Earth, whispers of life. At conferences from Baltimore to Paris, the debate turns heated. Some theorists scramble to patch the standard model with tweaks, adjusting star formation rates, dust laws, or the initial mass function, while others push for radical new ingredients. Early dark energy, warm dark matter, and even modified gravity all take center stage. Nobel laureate Adam Rees stands firm, pointing to the cosmic microwave background as a bulwark. He cautions that we must verify the James Webb Space Telescope redshifts before declaring a crisis. Meanwhile, NASA's Roman Space Telescope quietly shifts its deep field strategy, funneling millions into expanded surveys. The stakes now stretch beyond equations. Mission budgets, reputations, and the very story of cosmic origins hang in the balance. Somewhere, a new image is still downloading. Pixels assemble in the dark, carrying messages from a time before Earth had oceans or air. Each revelation sharpens the mystery, but the next transmission could redraw the map again. For now, the universe holds its breath, and so do we. Right now, our most advanced telescope returns evidence we cannot fit into any accepted theory. Discovery outpaces explanation. The universe refuses to be tamed, and every answer only deepens the mystery.